Greetings to all. Myself, Dr. M. Shakti Mohan, Associate Professor. In today's video, we are going to discuss about Verilog HDL code writing for combinational logic circuit. Also, we are going to discuss about the HDL basics and the types of HDL and how to write the code. So we'll discuss one by one. So we'll enter into the video. Okay, so first we must know about what is HDL. So HDL, the expansion of HDL is a hardware descriptive language. So if you consider about the CSE department and IT department, so they may have a lot of codings like C, C++, Java, Python, .NET. Okay, so likewise in our department, that is VLSI department, so we have a code called HDL, that is hardware descriptive language. So if you want to make a circuit design in the Cadence or Vivado like Xilinx software, so the HDL is very much important. So without the HDL, we can't able to make the circuit designs in that circuit in that software. Okay, so in the HDL, there are two types. One is Verilog HDL, another one is VHDL. So the expansion for the Verilog HDL is verification logic hardware descriptive language, and the expansion for the VHDL is very high speed integrated circuit hardware descriptive language, right? Okay, and also if you want to write the coding in Verilog and VHDL, so there are three modeling is available, right? That is data flow modeling, behavioral modeling, and structural modeling. Okay, so with the help of those only we are going to write the coding, right? And one more important thing, if you want to write the code in the Verilog or either Verilog or VHDL, so for that the basic knowledge required is digital electronics. Okay, so you must complete the entire thing in the digital electronics before entering to this HDL, because uh, whatever the modeling you are going to follow, so you need either the output equation for the particular circuit or otherwise the final logic diagram for the particular circuit. Okay, so without knowing that, you can't able to write a single line in the Verilog HDL or VHDL. So if you want to know the output equation or final logic diagram, so for that uh, you have to complete, you have to study and complete the digital electronics first. Okay, that is very important. Okay, let's get into the video. Okay, so we'll see. So since I already told you, there are three ways to write the coding. That is gate level or structural modeling, and data flow modeling, and behavioral modeling. Okay, so for today's coding understanding purpose, I'm just taken a circuit called full order. Okay, so you know that the output of the full order, right? So since the full order having two output, that is sum and carry. So the first sum output is equal to A XOR B XOR C, and for the carry, A into B plus B into C plus C into A, right? So this is the output for the full order, right? So if you want to write the coding in terms of data flow modeling and behavioral modeling, that is data flow and behavioral modeling, now for that you need the output equation of the particular circuit. Okay, so likewise if you want to write the coding through gate level or structural modeling, now for that you need the final logic diagram for the particular circuit. Okay, so we'll discuss one by one. Okay, so the first coding is data flow modeling, and so today we are going to discuss the Verilog HDL code only. So VHDL we will discuss it in the later part, right? Okay, so first data flow modeling. So every program starts with the module. So module, and then you have to mention one name for the program. Okay, well, since it is a full order, I am just mentioning full underscores add. Okay, so if you want, you can mention your name or register number also here, right? And after that you have to mention a open bracket, then you have to mention the inputs and outputs which will be present in the circuit. Okay, here it is a full order. A, B, C in is the input, and sum and C out is the output, and then close bracket, and you have to mention with the, that is you have to mention the line with a semicolon. Okay, don't forget in the Verilog HDL and VHDL, each line is ended with a semicolon. In some cases, like some library functions alone, no need to mention the semicolon. Okay, so apart from all, so you have to mention the semicolon. That is each and every line is ended with semicolon, right? So once you completed the first line, so the next line is you have to mention the input alone, right? So input A comma B comma C in and semicolon. And after that you have to mention the output alone, that is output sum comma C out, right? Okay. So first the program name is declared, and after that input declaration is over, then output declaration is over, and then the body of the program. Okay, so this is what the body of the program. And since it is a data flow modeling, so the assign keyword is used to mention the output, right? So assign sum is equal to A XOR B XOR C in. Actually, this is the symbol for which will be used for XOR, and this is the symbol for and this is the symbol for OR gate, and this is the symbol for NOT gate. Okay, but don't forget. Okay, since we are going to use the XOR gate, so A XOR B XOR C in, right? And after that, the C out output equation, that is assign C out is equal to A and B or C in and A or C in and B. Okay, so once you complete the entire thing, you have to mention the end module. Okay, the program starts with module and ends with end module, and for the end module there is no semicolon, also there is no space in between the end and module. Don't forget, if you put space or semicolon for the end module, definitely the error will occur, right? Okay, so this is what the way to write the Verilog HDL code in terms of data flow modeling. So the next one is behavioral modeling. Okay, so this is what the behavioral modeling, and don't consider this bracketed item. Okay, this is the next way of coding. Okay, so data flow modeling and behavioral modeling is more or less same only. Okay, so the structure is 90% is same only. Okay, so again, module full add, that is the name of the program, A comma B comma C in comma C out comma sum, right? And input alone you have to declare, and output alone you have to declare, and then two more keyword we are going to use it in the behavioral simulation. Okay, so that is behavioral modeling. So register alias reg you have to mention. So in this reg you have to mention the output of the program. Okay, so the output of the program is sum and C out, so I'm just to mention it here. And after that, always at, so in this you have to mention the input of the program. Then begin and sum and C out, the previously we mentioned, no, so just like that we will mention. And after that, for this begin you have to mention one end here, and for this model we have to mention a end model here. And don't forget, don't mention semicolon as well as space in between the end and model, right? So this is how we have to complete the behavioral modeling, right? Okay, so the next thing is gate level modeling. So gate level modeling is easy compared to the remaining two modeling. Okay, so gate level modeling you need the output logic diagram. Okay, so for the data flow and behavioral modeling the output equation is required, but for the gate level modeling the output diagram is required. Okay, so don't forget. Okay, so you can see since we are going to program it for full order, so the some output for the full order is A XOR B XOR C. So for that the logic diagram here I'm just mentioning. And likewise for the C output, this is what the output equation, that is A into B plus B into C plus A into C. For that I'm just the logic diagram. Once you completed the logic diagram, you have to mention the inputs and gate name. Okay, so gate name means here I'm just mentioning G1 as a gate name, G2 here, G3 here, G4 here, and G5 here. Okay, also I'm just mentioning some additional terms here. You can see that is T1, T2 and T3. So what is those T's now? It is called wires. Okay, so generally what is wire now? One gate's output is given to another gate's input now, that is what wire, right? See here, you can see the G2's output is given as a G5's input. So that is why here I'm just to mention as a wire as T1. Likewise, G3's output is given to G5's input. That is why the T2 is mentioned. Likewise, the G4's output is given to G5's input. That is why T3 is mentioned. Right? Or likewise, the wires will be mentioned here. And after that, we'll enter into the program. So gate level modeling, module, the name of the program, input comma output. And after that, input alone you have to mention, output alone you have to mention. So once you complete the input and output declaration, after that, since it is a gate level modeling, you have to mention the wires also. Okay, so wire T1 comma T2 comma T3 semicolon. And after that it is very easy. So by seeing the gate structure, you just mentioning the output equation, output declarations. Okay, you can see. So the first gate structure is XOR, no? So XOR G1, that is you can see here, XOR the gate name G1 bracket la output comma input you have to mention. You can see the XOR gate output is sum and the input is A comma B comma Cin and colon. Likewise, you have to mention the remaining gates also, that is and G2, the output of the G2 gate is T1 comma A comma B. Likewise, the remaining two AND gates and the final OR gate. So once you completed the entire thing, the final line, end model, right? So I hope you understand the today's content. So today we discussed about the Verilog HDL code writing for combinational logic circuit. Also, we have discussed about the basic of HDL, that is the expansion, hardware descriptive language, and the types, that is Verilog HDL and VHDL. Also, we wrote the code, that is a full order code with the help of three modeling, that is behavioral modeling, data flow modeling, and structural, that is gate level modeling. Thank you.